Hello YouTubers, welcome to my messy shop where the rules are made up and the points do not matter. So I've been wanting to make a CNC machine for many years now, and I finally did it. I had the pleasure of running a CNC plasma cutter for a couple months for a friend of mine, and he had a nice huge table, water table. Yeah, the whole works, man. Nice place. Well, he lost his shop just like I did in the North Carolina flood of 2024. But anyways, ever since then, I was like, one of these days, I'm going to build a CNC machine. My project began with a small pile of CNC parts that friends had given me throughout the years. I didn't know anything about CNC machines, even though I was operating one. I knew how to click the mouse and make it go. I never understood what was going on behind the curtain. One thing I did know is that I need motors, and I knew that the motors ran on drivers. I am experienced in Arduino, so I knew basically how the stepper motors operate, but I had no clue what was going on in the computer. So I'm a carpenter by trade, a machinist by hobby, and in the art world, I've always wanted to marry the two together. I'm hoping the CNC machine will be the priest that joins them. I squished the bit size. So, one day I had some money, and I bought the motor kit, drivers, and power supply. And the kit came with a Mach 3 board, but I'm running Linux, so the Mach 3 board don't run on Linux, only runs on Windows or Mac. So I had these gear racks. They're about 4 foot long, about, 122 centimeters. But the weird thing is that I actually had matching gears. So I had 2 of them, 2 sets. It was perfect for this build. The gears had a shaft on them, and I think that's about, what is that? I don't know, 100 millimeters or something. Anyways, I had to bring it down to 8 millimeter. So I bored a hole in the end of this, rammed a 8 millimeter piece of steel in there, yada yada, and I made this belt drive work. This project, not only did it start with the new motors, but I had a router sled. This sled is what I used. I put a router on it, and I had this angle iron track. And I would put a tree slab on there, and I was able to plane stuff flat by hand. But I had this track that I was using, and that, was able to get a nice parallel slab. Matter of fact, here's some slabs I did after they got flooded, and they were up in the rafters of my darn shop. Crazy as it sounds, but I had to retrieve these from the rafters. A piece of red oak and a piece of pine. I'm using them for steps now. My x-axis, it actually was already made. I just had to cut it out of a frame. And the motor that was in it, obviously it was gone and wasted, but it had that belt drive on it, and these rollers, this whole mechanism, I was able to just chop it out and weld it to this frame, and it's a belt, long belt. If you look, see, there's the teeth. This stuff was in the North Carolina flood, so you're still seeing flood mud on there. So my Z-axis, I had this stainless steel commercial industrial thing laying around that I got at the metal recycle, and I wanted to use it because this pivot point, I don't know if you can see, and the other pivot point right there, they are perfectly parallel to each other. I didn't want to try to recreate something like that, so I chose to use this part. So I wanted to keep the plasma out away from the motors because the plasma EMP, the electromagnetic pulses, really interfere with the signals coming to the motor. So I was like, well, I'll just keep the plasma away from the motor. That makes sense. So I did this seesaw thing. And the back side of the seesaw is connected to the Acme thread that goes to my Z motor. I put this stainless steel counterweight on the seesaw to help this little tiny brass nut that's on the Acme thread. Otherwise, there's a lot of weight on it, especially when I put a router on end of this. It gets really heavy that way. So this weight just helps it out. Here's another view of the Z motor. If you'll notice, there's a brass nut on the Acme thread. I wanted a plasma cutter and a router, so I chose not to do a water bed. Obviously, we're outside, so I don't need a water bed. I freehand plasma all the time without water. What's the difference? As a carpenter, people are always giving me stuff. So I have a big pile of rebar out in the woods here, and I got endless supply of rebar. So I use that to put my metal on, and it's a good consumable that I don't give two hoots about. At the business end here, this is that stainless steel piece coming, and I had to make some brass bearings and a stainless steel pin and some linkage to keep this front plate straight as it elevates. This is just a chunk of stainless steel pipe I had laying around. I haven't really figured out where to cut it off yet, so I just leave it for now until it gets in the way. I machined this piece of aluminum to receive my plasma torch, and then I didn't want the weight of the hose pulling it down really hard, so I have a wire attached here and connected to the top just to take some of that weight off of the neck right here. So this is what turns the plasma on and off. I made a yoke that clamps and just some simple wiring, really light. I don't want to add friction to it. The solenoid clicks and pulls the button. I have a flyback diode on the solenoid because that's a serious issue. When a solenoid turns off, it throws a reverse high voltage spike, essentially making an automotive coil to fire a spark plug. The flyback diode takes care of that problem. My machine is the Prime Weld Cut 520 DP. I really love Prime Weld stuff. I'm going to get some more of their stuff. This is a combination DC TIG plasma cutter / DC stick welder. Unfortunately, I bought the machine thinking I was going to weld aluminum, and I didn't know anything about welding aluminum, and I bought this machine and realized that you need AC to weld aluminum. So right now it's just making a damn good plasma cutter. It works really well, and when you call their phone number, an actual human actually answers the phone. So building the actual machine was like 5% of building this CNC machine. This sumbitch gave me more headaches and more gray hairs and more sleepless nights than any girlfriend I've ever had. So we are looking at the $150 pawn shop special. That's what I wanted. It had has a disk drive, which the other laptops did not. It came with Windows 11, so I immediately wiped it with dban, otherwise known as Derek's Boot and Nuke. It wipes the hard drive clean, and I was able to load up Linux Mint, and I've been running the Mint ever since. And I gotta say, after I learned it, I love it. I'll never go back to Windows or Mac ever again. So I had a one of those stupid electric fake fireplaces. That's what this box is. And I wanted to use it because it had a glass on it, you know. It's pretty cool, right? So this was the vent, and I had to fill this in with some stainless steel right here. I welded some hinges on now. But what's cool is it's well ventilated, and it came with a blower. So I have a blower up there that sucks the heat out, and it actually works pretty darn well. It's oversized. I don't need it that dang big. It's a big space taker at the moment. I'm cool with the machine taking up space as long as it's worth it. So I bought that motor kit. It came with 3 motors, 3 drivers, power supply, but it also came with this Mach 3 board, right? So I connected this, yada yada. I spent like 2 weeks trying to get the sumbitch to work, could never get it to work. It's not a Mach 3 board. So it says Mach 3 board, but it's not. What I learned is that this is a Chinese clone, and the sumbitch is a little tweaky, a little different. I don't know, but I could not get it to go. It came with the disc. I ran the disc, blah, blah, blah. Nothing happened after 2 weeks. Gave up on it. Anyways, I discovered this guy on YouTube, and he swears by the ESP32 chip. So I was like, yes, I'm going to do that. So I bought this ESP32 chip. Here's what's up. We have a ESP32 chip, but it's sort of a hybrid, right? It's designed for CNC, and it's made to run motors. It also has Wi-Fi and Bluetooth capabilities, but I haven't gone there yet because I'm trying to, you know, slack off on the gray hairs I've been gaining lately. So the machine works right now, and I don't want to fucking mess with it, any of it. So if you don't know, the ESP32 chip is a general purpose chip, and it runs all kinds of things from printers, robotics, you know, they use it for lights and switching, and it has all kind of capabilities. But one of the capabilities it's really good at is running motors. And Arduino guys like this ESP32 chip. I love it. Once I figure it out, it's great. So this is a macro base board. It's a Chinese clone of the Maker base board, but I didn't know that when I bought it. So I clicked on like the first thing I saw on Amazon. It was a 6-axis board, and I was like, cool, that's the one I want, right? I ordered it, and I had no idea that this sumbitch was a clone, and I ran into a lot of problems with it. And there is a gentleman on YouTube who finally solved my problem. As with any chip, it needs certain commands to make it even turn on, right? So when you turn on your computer, there's a boot menu. There's a boot thing that happens, right? Like, even before the computer itself, the software to make the menu and all that shit come on before that even happens, there's a firmware, and that firmware is what tells the computer simple things like to turn on the keyboard and to turn on the monitor and to turn on sound. This ESP32 chip has Fluid NC, and what it is my understanding is that it is a hybrid version of Gerbil. And Gerbil is just the basic functions that you load onto this chip so that when you plug it in, it turns on and it has some basic commands. All this other stuff you see around the basic ESP32 chip is just bells and whistles to make the motors work, to make them work efficiently and well, and yada yada. So anywho, Fluid NC runs with a file called a YAML file. It's YAML. And this file is where it stores things like motor speeds and acceleration and soft limits and all kinds of weird stuff like that that actually control the motor behavior. So I spent weeks with this thing sitting on my desk. I had a motor hooked up to it, had the power supply going, and all I wanted to do was get this motor to turn, and it would not freaking turn. For weeks I spent Googling YouTube videos, forums, you name it, I was there. I tried every piece of software. Oh my God. So I watched a gentleman, his name is Miles, at New Tech Creative YouTube channel. And I left a comment. It was a snarky comment, but he replied back and offered to help. And this gentleman actually helped me solve my problem. The problem I was having is with ins and out pins. So each one of these pins on this chip has a designation, has a reason for being there. And it needs to be linked to the motors in a certain way, right? I was using generic YAML files and could not get the sucker to work. Camera's not focusing. God damn it. So Miles, he emailed me personally and we exchanged emails, and within a couple of days he figured out my problem. And the problem was that I needed the macro base YAML file. No other file will work. It had to be a macro base YAML file. So anyways, we downloaded that thing onto this sucker, and it's been working like a little mule ever since. So I have my 4 motor drivers, power supply. I learned the hard way that metric is the right way. So I don't even mess with imperial no more. This whole machine runs on metric. I ran into so many problems with the transferal from inches to millimeters in the software itself, in my workflow. Screw that. Just go millimeter. The rest of the world is using millimeter, yada yada. So anyways, there's my table clear-cut dimensions. This is the switch that turns on the plasma. It runs that solenoid. So I have it wired into, I believe it's the lubrication switch. So when you push play on the controller, it turns this on with a M3 Gcode command, and I have to take care in making sure my M3 is in the right place in my Gcode command. This thing works great. It's a little analog. It just takes that small switch and turns it into a large current coming from the power supply and feeds the solenoid. The solenoid, unfortunately, I screwed up, and this is a 24 volt system, and I bought a 24 volt solenoid. Don't do that. I should have bought a 48 volt solenoid so that the duty cycle would be more like 100%. With a 24 volt power supply and a 24 volt solenoid, I do not get 100% duty cycle, and the solenoid will overheat. It gets really hot. So I added a 25 ohm resistor in series with the solenoid to try to take some of that heat away from the solenoid. Okay, back to my girlfriend. This thing, oh my god. Oh my god. I can't tell you how many gray hairs I have gotten from this sumbitch. But I finally figured it out. I cracked the code, folks. So as I said, I got this computer at the pawn shop for 150 bucks. It had Windows 11. I wiped it, put in Linux Mint, and now I'm ready to do some CNC stuff, right? I really wanted to run the CNC machine on open source. Yes, I know I can buy some really cool programs, and I'm gonna do that. I have some cool software on my shopping list, in my shopping cart. I'm ready to buy, but I wanted to learn this stuff before I just go aimlessly buying software that is gonna just waste my money. So there's a process to this CNC machining world, and it's called a workflow. The workflow is how you start your drawing, you chain it, and you end up finally with a Gcode that makes your motors run. I'll tell you my workflow, and I guarantee you this is the easiest workflow for open source newbies. Please heed this advice. If you don't know it, Librecad is the cat's meow for newbies. To hell with FreeCAD. FreeCAD, I spent months on FreeCAD. So I was trying to learn FreeCAD even before I ordered motors. Before I even started this machine, I was like, well, I know I have to learn some drawing, right? So I was like, I'm going to draw some D-rings. If you don't know what a D-ring is, it's like a D-ring. It looks like a letter D, but it's for welders. And you can weld it onto stuff and use it for lifting or for clamping stuff together. It's a very handy little chunk of metal for welders. So I was trying to design a D-ring in FreeCAD. I spent months on that sucker and was never able to export a DXF file. The DXF file is what you need to get into the CAM program. After months of dicking around, I finally discovered Librecad. Librecad is very user-friendly. I wanted my first cut to be the ace of spades because I love Motorhead. It was the hardest thing to do on FreeCAD, but I was able to do it on Librecad in a few minutes. Well, I shouldn't say a few minutes, maybe 20 minutes. And within an hour, I was able to export a DXF file of the ace of spades. So once you make a DXF file, you can then load it in this really cool open source program called bCNC. If you'll notice right here, I'm in what's called the editor menu, and the camera is not cooperating, but there's an image of the ace of spades there in red. There it is. You can barely see it. But if you notice over here is the Gcode. When I click on a line of Gcode, it shows the arrow of the little section of line it's cutting. It's so awesome. Go down here, click another line. There it is. And if I scroll down, click on the last line, guess what it shows? The last cut. So Gcode is really cool. It's simple. So if we look at our Gcode on this ace of spades, my Z height starts at 10 mil, and then it jogs over to the start of the cut. Then it lowers down to 0Z. It turns the plasma on. It waits for 0.125 seconds before it starts traveling, because we need the plasma to pierce through the metal before it actually starts cutting. And then this is that first cut. You need a lead-in for plasma cutting, because that piercing makes a nasty hole. You don't want to start your nasty hole on your part. So you start the nasty hole back here, and then you travel into the actual cut. So that's that first cut. This is just a human, what do you want to call it? It's not Gcode. It's just a human interpretation. So the machine automatically goes from there down to here and starts the cut. This is all the spades. Right here it does the spade cut. And at the bottom, M5 is what turns the torch off. And then the Z height goes to 10 mil. And there's a little footer, but it's just redundancy. It's just saying go to 10 mil and shut the torch off again, but it's backwards. So for newbies, I highly recommend bCNC, open source software for your cam. It works really well. There's a small learning curve at the beginning, just like trying to figure out how to click on stuff. But once you figure out how to click on certain things, it's go time. Like, everything just happens so fast. So to run my motors, I'm using Universal Gcode Sender. I tried Linux CNC. I could not get the sumbitch to load on this computer. I tried probably 21 times and it just would not load. It kept freezing up, and so I gave up on Linux CNC. I was like, there's got to be a better way. And I tried everything, folks. I promise you, I tried every open source software there is to make your motors run, and actually to do all of this. The CAD CAM motor controller process. And this is the way to go. I promise you, folks. I'm teaching you some cool stuff. So Universal Gcode Sender is really cool. It shows the Gcode right there, and it actually runs the Gcode as you push play and watch your machine cutting. And you can edit the Gcode. So it's real easy to manipulate. Even in this menu, I can rewrite my Gcode, no problem. And it's pretty cool for manipulating little things like when the torch comes on and off and yada yada. So overall, I've been really happy with this machine. It works better than I thought it would. I thought it was going to be, I didn't know what to expect. So I want to give a big shout out to Miles at Tech Creative, and without him I would have never figured out the Chinese ESP32 chip. We are rocking and rolling. Thank you.